Hi everyone, myself Venkatadivya, studying in Sri Venkateswara College of Engineering, Bangalore, Department of CSE AI. Today, in this video, I will be talking about merge sorted list. So first, I will give introduction about merge case sorted list. Merging case sorted list is a common problem in computer science. It involves combining of multiple sorted lists into a single sorted list. This concept is essential in various applications including merging results from different data sources. Now, problem definition. The task is to merge a k-linked list, each of which is sorted in non-decreasing order. The goal is to produce a single linked list that contains all the elements from the K list, also sorted. Understanding the problem helps in choosing the right algorithm of an efficient solution. Next, input format. The input consists of an array of K-linked lists. Each linked list can have varying length and can be empty. The output is a single linked list that represents the merged sorted list. So there are types of linked list, that is single linked list, double linked list and circular linked list. Next is the output format. The output must be a linked list that retains the sorted order of element. The merged list should not contain any duplicate nodes unless they exist in the input list. The output list must be represented in a suitable data structure, typically a linked list. Next is example scenario. Consider the three sorted linked list which has been given and merge them should yield the sorted linked list. This example illustrates the merging process and expected output. Next is naive approach. A straightforward way to merge a k-sorted list is to concatenate them and sort the result. This approach has a time complexity of omega O of means complexity of n log n, where n is the total number of elements, while simple it is often inefficient compared to the other methods. Now, optimal approach overview. More efficient algorithms exist that can merge k-sorted list, that is omega of n log k time. This is the time complexity of sorting the linked list. Next, these algorithms utilize a minimum heap priority queue to keep the track of the smallest element. The strategy involves repeatedly extracting the smallest element from the heap. Now, using a minimum heap is a complete binary tree where the smallest element is always at the root. Each list head node is added to the minimum heap initially. The process continues by extracting the minimum heap and adding the next node from that list until all nodes are proceeded. Next, detailed algorithm steps. At first, we have to initialize an empty minimum heap and insert the head of each list. Next is repeatedly extract the smallest element from the heap and then add into the merged list. Next is until the next node from the extracted node list into the heap until all the nodes are processed. So in this, we have to first initially find the minimum heap and insert into the list. Like that, we have to continue the step until the heap all the nodes are processed. Next, time complexity analysis. The time complexity of merging k-sorted list using a minimum heap is omega n of log k. Here, n is the total number of nodes across all lists and k is the number of lists. This efficiency makes it suitable for large data set with multiple sorted lists. This is the time complexity analysis. Next is space complexity analysis. The space complexity of this approach is omega of k due to the storage of list heads in the minimum heap. Additionally, the space for the output list must be considered. Overall, the space used in is proportional to the number of lists being merged. This is the space complexity of a linked list. Next, implementation in Python. Now, we can use the merge sorted list in Python. It provides an efficient way to implement merging using the heap library. The library allows easy manipulation of the minimum heap structure. Sample code can be demonstrate the merging process clearly and concisely. Next, implementation of code example. Here, the brief example of implementation in Python, or as well as it is mainly used in Python C programming. The code initializes a minimum heap and iterates through the list effectively. This example provides clarity on the practical aspects of the algorithm. Here is the decision node, which is a root node, and leaf node, decision node, which is the subtree. Here is the handling edges cases. The algorithm should handle cases where some lists are empty. An empty list input list or all the element list should return an empty merged list. Special conditions should be accounted for to avoid errors during merging. Next is the alternative approaches. Other methods such as divide and conquer method can also be used. The divide and conquer method approach merges lists in pairs recursively. This method has similar time complexity but may be easier to understand the concept. So here is a problem which has been divided into subproblem 1 and subproblem 2. Then again that is divided into subproblem and solve the problem and arrange them in the ascending order, and then combine the solution. Based on this, we have to merge and sort the list, which is called as divide and conquer method. Application of merging. Merging sorted list is commonly used in data analysis and processing. It finds application in algorithms for merging multiple data sets. The concept is also essential in algorithms like the merge sort. Now real world examples, which is based on the merge sort. In real-world application, merging k-sorted list can be seen in search engines. Search engines often merge results from different data sources to provide a comprehensive result. Another example is merging log files from various servers for analysis. Now, conclusion for merging k-sorted list is a valuable skill in computer science and programming. Understanding various algorithms, including native and optimal approaches, enhances the problem-solving skills. The use of data structure like heaps can significantly improve efficiency. So approaches for Burette force solution: compare 1 by 1, compare 1 by 2, approach 2, maintaining a priority queue, merging list 1 by 1, and divide and conquer. Here is the time complexity and space complexity for each and every solution and approaches. This was the conclusion of merging the k-sorted list. Thank you. I hope this video will be helpful for you. Please like, share and subscribe for more.